again, let's identify our domain and our range. Inputs to this function. Again, we need to check our rules for what we're allowed to use as inputs. Our rules for inputs, at least with respect to this function, says make sure you're not square rooting negative numbers. So what kind of values can I put in here? I can put any non-negative number I want into this function. Okay? Notationally, again, like the range from the previous problem, anything from 0 to infinity. Okay? All right. Now along those same lines, we want to look at what kind of values come out of this square root function. What can we get out? In this case, if we want to identify the range, we notice that any of those domain values could be a possible output as well. So our domain and range here are exactly the same. And there we have it. All right. Let's try one or two others. Let's take h of x equal 1 over x. We're going to identify our domain and range here. What do we plug in to this type of a function? Okay, in this case, the one rule we have to make sure we're not violating is we never can divide by 0. So we can put anything we want in here as long as we don't include 0. One way to write that is using this notation. Again, there are two separate intervals. We have the negative infinity to 0 interval, the 0 to positive infinity interval, and then the u in the middle just means to include both of those sets. Just some math shorthand. If you've never seen it before, it stands for union. Union, two sets, throw them all together. Okay. All right. Now again, we can do the same thing. Look at what kind of outputs does this function afford us. What do we get out of this function? We get all real numbers?
Except for 0.
All right. We can get almost all real numbers. The only one we can't get is, again, 0. And there is our range in this one. All right. Now, again, if you've never seen this function before, if you're not 100% familiar with it, you may wonder, well, why can't we get the 0 out? Well, with a function like this, right, when we have a function that's displayed as a fraction, the only way this fraction will ever be equal to 0 would be if the top is equal to 0. Since the top is constant at 1, this thing will never equal 0. You just sort of finding the range of functions like this, again, you're just sort of trying to play around with it. You try to see, well, what happens as I get larger and larger numbers in here? Well, as x gets really, really, really big, 1 over x gets really, really small. So you can kind of use your intuition like that to identify the range when working with functions of this type. Okay, let's do one more. This one's a little more challenging, maybe. K of x, 1 over quantity x squared plus 1. Identify the domain of this function. What can we put in here? Are we ever going to have to worry about dividing by 0 in this particular problem? No. We don't have to worry about that because the thing in the denominator is x squared plus 1. This is always going to be positive. So we don't need to worry about dividing by 0. If we're not worried about dividing by 0, if there's no square root signs running around anywhere, there's really no restrictions that we have, right? We can do anything we want with this function. We can put in any value we want. So our domain here, all real numbers. Now we get to the tricky part. What comes out of this function?
Anything greater than 1. Because if you put in 0, then you want to 1.
Okay, we can, if we look, we obviously, we can get 1 out. 1 certainly comes out of this function, right? If I plug in x equals 0, I get 1 out. So 1 is in the range. And what else?
Anything between 1 and 0.
Okay. One conjecture we have so far is that we can get out any value between 1 and 0. Okay. All right. We cannot get 0 out. Obviously, again, as a fraction, The only way that fraction would ever be equal to 0 would be if the top is 0, top is 1, so I know it's never going to be equal to 0. I can get the value 1 out. And so right now we're guessing, unless you know exactly what the graph of this looks like, exactly what this function looks like, we're guessing that our range is between 0 and 1. How do we know for a fact? Well, knowing for a fact requires us to either have other knowledge about this function or in some way try to test and see that this is in fact the range. How can we do that? Well, let's take a look at this function by plugging in some values. Okay, let's just take some values, plug them in, see what happens with this function. So we'll try some negative values, -5, -3, -1, 0. We'll try some positive values, 1, 4, 6. Okay. I'm going to try these values. I'm going to just plug them into our function, see what kind of values come out. Okay. All right, so I plug -5 in here. What do I get out? Okay, I should get 1 over 26 out. I plug -3 in. Plug -1 in, get half. I plug 0 in, they get 1. Positive 1, half, 4, 17, 6, 37. So this table that I've drawn here gives me some sort of good evidence that, yeah, it does in fact look like this is going to be my range. Okay? And what I can further do is I can utilize this table here to sort of identify what the picture that this graph gives us looks like, or that this function gives us looks like. So let's take a look at sort of plotting some of these values and seeing what this graph looks like. And this isn't going to be 100% to scale because some of those values are very small and I want a big picture, so I'll try to get this to be a little bit larger than the scale would represent. Okay? So first thing I'm going to do, I'm just going to start by plotting these points. Okay? Plot these points and see what I get. Okay? So here's my 6 over here, 137. Oh, I'd say it's about that high. Working backwards across here, 5, 4, 3, 2, 1. Okay, at 4, 1/17. That's about, I'd say right about there, give or take. Okay. At 1, I get a half, so that's like right about there. Okay. And moving to the other side, -1. -1, 2, 3, 4, 5. -1, I'm also at a half. And then continue plotting these other values. At 3, I'm at a 10, so maybe right around there. And then at -5, I'm at 26, so right around there. So these points right here should sort of give me an indication of what this function looks like in terms of its picture. Okay? Now, you can ask the question, okay, well, how do I connect the points to make sure the graph looks right? How do I know that the picture doesn't look something like this? How do I know that's not the graph of this function? And how do I know what goes on between each of these points? Obviously, this is not the graph of this function, so I don't think that that is. But how do I know how to connect these points? Well, in calculus, and in this class in particular, all the functions that we're going to be working with, most of the functions we're going to be working with, are going to be nice functions. And what does nice function mean? Nice function means that these functions are going to be relatively smooth, meaning that the connection from one point to the next is not going to be some sort of jaggedy line or some sort of wavy squiggle. They're all going to sort of smoothly mesh together, and we're going to get a nice picture that doesn't necessarily have any jagged edges or wiggly squigglies running around in them. Okay? So the graph of this function, as we smooth these points together, should look, this is a very rough picture, should look something